Hey, what's up folks at home? Ever since the world found out about my exotic Debra 2 plant, I haven't been able to keep her as well fed as I should. So we're gonna show you how to make a moisture sensor. Little shop of moisture, bop shoo up. Alright, so as always, we need a few things to get this going. We'll need an Analog Devices microcontroller, specifically an Adicup 360, an Analog Devices moisture shield, a capacitive moisture sensor, a PC, 2 micro USB cables, your own Debra 2 plant, and some water. Today we'll be using an Analog Devices MCU board that has the same form factor as an Arduino, which easily makes it compatible with Arduino shields and similar devices. We'll be using this capacitive moisture sensor here to detect the moisture level of our Debra 2 plant. See? So you just stick it in the soil. I love being a florist. A capacitive moisture sensor senses moisture with capacitive sensing rather than resistive sensing. Capacitive sensors are resistant to corrosion, so they'll last a long time in wet environments. As the product senses moisture, it outputs an analog voltage inversely related to the moisture level. So the wetter, the lower the voltage. This means that we can use it with any board that supports analog inputs, like our Analog Devices moisture shield we have inside this guy. I couldn't find any Velcro, so it kind of just hangs there. We'll first need to attach the shield to the Adicup MCU board, and then we'll be able to attach the sensor's wires accordingly. And then you put it in this little Tupperware. I just cut some holes in the back here for the wires to come out. And now it's moisture resistant. Just don't pour water on it and you'll be alright. The shield will read the analog data and transmit it to our microcontroller via SPI communication. After tweaking some example code, with the help of the microcontroller, the sensor can tell us if the Debra 2 plant is dry, moist, or wet. Or in Little Shop of Moisture world, feed me, a little more, and satisfied. To upload the code, we'll actually need to use 2 USB cables. One connected to the user plug for debugging and upload, and the other for monitoring our results via the serial monitor. That's in my way. Open up the Adicup IDE. Follow the directions on the webpage for setting up a proper debug session for your specific application, and press debug. And when the debugging is complete, you'll need to hit stop. Using a built-in serial monitor or a third-party serial monitor like ours here, set the proper baud rate and look at the data flow. Oops, that's ready. A little more. See, it comes up on the screen there. And then you give it a little more. Woo! Yeah, Debra 2, drink up. Our sensor's output range is between 0 and 3.3 volts. I divided this range into 3 different sections that correspond to the 3 different moisture categories. Satisfied. She's satisfied! I mean, that's a wet plant. It's dripping into this cup.
Feed me.
A little more. A little more. A little more! Satisfied. The sensor, with the help of the... After tweaking